Welcome, and this is going to be the first in a series of videos on design patterns, and not only design patterns but also UML using the visual paradigm package to set up class diagrams. Okay, so we'll try to tackle both of these in one set of lectures. So the motivation for looking at design patterns is that it's actually kind of a hard problem to solve to set up a whole bunch of interacting classes. So when you design a single object, well, that's pretty easy. Well, you probably know from designing objects that you can design good objects and bad objects. There are good designs and bad designs. But a single object is comparatively easy. On the other hand, designing interactions between objects is a little bit more difficult, especially if you want to do it right, if you want to set up good interactions between objects that are designed well. Okay, so that's a little harder, and that's hopefully by now you're getting better at it. So developing good software is hard, and developing reusable software is even harder. So it's hard enough just getting software that works without bugs. Now, to take it to the next level, you want to design software where you can reuse components of that software. That's even harder. So one way to do this is to leverage proven solutions to common problems, and that's the whole idea of design patterns. So there are two general ways to do this. That is design patterns and frameworks. We will be looking at design patterns, and we'll compare design patterns with frameworks. So the one thing that we're going to tackle is design patterns, not so much frameworks, is because that involves a lot more coding. There's a lot more ideas and important things like that in design patterns. The whole idea of design patterns is to support the reuse of architectural design. And you capture static and dynamic structures and collaborations of successful solutions. The idea is to, once you see a good way of doing things, you try to capture the idea, the architecture. That's what architecture means, is just how the classes interact. And that whole idea of how classes interact, you want to reuse that as much as possible, because chances are you'll use the same kind of interaction between classes elsewhere when you're solving other problems, other coding projects. Okay, so frameworks are good. They do support the reuse of detailed design and code. So there's a lot more reuse of actual code in frameworks. They usually provide an integrated set of components for partial solutions to problems. So they don't solve complete problems. They are tools that you can use within a defined set of parameters. And the nice thing about frameworks is that they give you code, actual code, that solves a lot of problems. So there's a lot of literature about design patterns. So there's a book, for example, and one called Java Design Patterns. This is pretty old, but I refer to this quite a bit in the lecture. So if you take a look at this book, you'll see a lot of stuff that I took, basically ideas that I took directly from this book, Java Design Patterns. Okay, so now, what exactly is a design pattern? So there's many different definitions. You definitely want to read about these things. There's a nice Wikipedia site. Let me just pull that up. There it is, software design pattern. And gives you the history, tells you how it's used these days. And then there's a huge classification, which has been greatly expanded over the years. It's about almost 20 years old, this idea. And we will go through quite a few of these patterns. I'm just quickly scrolling through this so that you get some idea. I know you can do this on your own, but just to show you, there's a lot of design patterns that people have thought about. And there's a core set, but there's quite a few in general, and people are still trying to create more. Probably every place that you go to will have their own special design patterns for their own set of problems. Okay, so here are some definitions. These are a design pattern involves recurring solutions to design problems you see over and over. So you solve a problem once, you solve a similar problem again, and then you try to abstract out what is common to those two similar problems. How did you come up with designs that work for both? Another way of looking at design patterns is as a set of rules describing how to accomplish certain tasks in the realm of software development. Okay, so set of guidelines for creating classes, essentially. Another way of looking at it is focus on reuse of recurring architectural design themes. I know this is all really abstract. These people like Copeland and Schmidt, this is a classic book. There's a classic book that they've written, was mainly for C++. Very nice design ideas for interacting classes. These are well-known computer scientists, and there's a lot of books on design patterns. I think if you're trying to get a start, definitely this Wikipedia page is where you want to start. Okay, so still, what exactly is a design pattern? It's not exactly a template. A template is a set of interacting classes that you can copy and paste. No, it's not exactly the same kind of idea. This design patterns can be implemented in many ways, and sometimes some design patterns are not even actually software designs. It's not exactly a framework. It's a lot more general in many ways. A framework is a set of classes that's almost a complete and application that you can, it's almost a standalone application that you can use from your program. So it's a lot more actual code. When you talk about a framework, you're actually talking about code. Design patterns actually in comparison are just ideas, just ways of organizing your programs. A design pattern is not written by a single programmer. This was discovered by design patterns were discovered by looking at many people's work and then trying to figure out a common approach or design idea. So design patterns address a recurring design problem. So you see a problem once, you see it again, and if you solve the first problem, chances are you can solve the second problem in a different context that arises in a specific context and presents a solution to these recurring design problems. This is by a person named Bushman. There's actually a series of books called Pattern-Oriented Software Architecture. If you're looking for a good book to read up, although this is kind of old, still pretty good. This is just volume 1, and there's, I think, at least one more volume, maybe 2 more, can't remember. The classic book on design patterns was written by 4 people. They're called the Gang of 4. The first author is Eric Gamma, and the way they define design patterns. So it's not just him, although he gets a lot of the credit. They define design patterns as a way to identify and specify abstractions that are above the level of single classes or instances or of components. So there was a lot of activity in computer science to come up with components, just like in electrical engineering. You had the idea of a resistor that was the same idea basically, and you just made a resistor as a component in a circuit. And in mechanical engineering, you had springs, you had hydraulic pistons, things like that. Those were components. There was a lot of people who wanted to set up components for software, and then once you set it up, it was all set. You just mix and match, and you get things working. That idea sort of worked, but didn't really work totally. If within a framework, you might see components that you can reuse a lot. So components are sort of like single classes, but they're trying to make the point that these design patterns are above the level, so that is one level higher. It's a set of classes that interact in a specific way. Okay, so they were working with C++. If you read their book, you would see that it is sort of dated. It's kind of a little bit, some of their ideas are a little bit clunky, but it's still good. people still refer to this book, Design Patterns, and actually it's in the library if you want to check it out. It is available, so you might want to get it from the library or buy it. You can get them used for 16 bucks. Okay, not too bad. Okay, so where does this pattern concept come from? So the history of design patterns is that it comes from architectural patterns. Certain patterns keep appearing. For example, pyramids. Pyramids showed up in ancient Egypt and also in Mexico and other places too. So in the Mayan Peninsula, we have pyramids. They're slightly different from the pyramids in Egypt. If you look at columns, the same basic idea showed up over many centuries, from ancient Greece all the way to Rome, to all across Europe, and then even in the US and elsewhere, you see certain architectural patterns that keep coming up. So each pattern, a software pattern, will be described by a short name, and so you'll see things like singleton and visitor, things like that. I'm trying to remember some of the names. And then you see a brief description of the context in which this pattern is useful, and then a lengthy description of the problem itself, including maybe a UML diagram. So UML is sort of a big part of describing patterns. It's not essential for patterns, but it sort of makes it easy to see what the pattern is. And then you see oftentimes you'll see an application of the pattern or something like a prescription for the solution. I do have to warn you, design patterns are described in different styles. Every author uses a different style for describing design patterns. The canonical description is in the book by Eric Gamma et al. So these are the other authors. The four of them together are referred to as the Gang of Four. They're still active in software design. This is almost 20 years old, but it's still good. These ideas are still good. People are still coming up with new patterns. If you want an online reference, this is a .NET a site. That is a site that talks about .NET software, and specifically they use C#, but it's basically the same as what you would use in Java. So they say it's .NET design patterns, but it's pretty language independent, although I think when you look at, for example, let's see, singleton, you'll see things like a definition. A singleton design pattern is set up to ensure that a class has only one instance and provides a global point of access to it. So it's true in any language. If you look at this UML class diagram, is very simple in this case. It's actually just one class, unlike most other patterns which involve two or more classes or interfaces. Okay, so nice thing about this is they show you sample code in C#, but you can pretty much understand it and it will make sense of it as a it's not that far from Java. So we will go over the Java version. So here is their C# version of the singleton class. So there's an instance. It's a static instance. Static data member, not an instance. This is a class with a static data member called instance. It refers to an instance of a singleton object. So this is something that we don't usually see very often. That is the class as an data member that is a reference to an instance of the same class. And you see a protected constructor, which is odd, and then you see a way to get that instance. Alright, so we'll look at that in the next video.